Welcome to this demonstration of Visual QKD Pro, an intuitive research-grade platform designed by Q Insight Labs to model, analyze, and visualize quantum key distribution workflows. Whether you are teaching foundational cryptography or evaluating quantum channel vulnerabilities, this interface brings complex quantum state mechanics into clear focus. Looking at the workspace, the software is divided into two logical zones. On the left, the simulation parameters and leakage security panels give you granular control over your quantum environment. Here you can adjust the total number of qubits, inject channel disturbance, simulate active eavesdropping, and configure post-processing budgets. On the right, the interactive workspace delivers immediate visual feedback via a human-readable simulation console, a live metrics board, and a suite of real-time analytical plots. Let's begin with a baseline experiment using a classic BB84 encoding workflow. We'll start by launching the application with its default block size of 10,000 qubits and utilizing the clean preset. Executing the simulation instantly processes the run. In this ideal scenario, the simulation console confirms successful base shifting, our quantum bit error rate, or QBER, rests safely at 0%, and we achieve an optimized long final key length. However, real-world quantum channels face environmental degradation. By manually increasing the noise percent slider or activating the noise 5% preset, we can introduce physical channel disturbances. Running the simulation again highlights an immediate shift. As disturbance scales up, our plots dynamically update. On the QBER versus noise graph, you can track the linear progression of the error rate, while the key length versus noise plot clearly illustrates how environmental noise degrades and shrinks the final secure key material. Next, let's explore threat modeling by toggling the Include Eve parameter to simulate an active intercept resend attack on the quantum channel. When we execute an adversarial run, the footprint of the eavesdropper is instantly exposed. On our analytics panel, the red Eve on curves dramatically separate from the blue Eve off baseline. At identical noise levels, the presence of an adversary causes a sharp characteristic spike in the QBER, while causing the secure key rate to drop significantly. To mitigate this threat, we turn to the leakage security controls. Visual QKD Pro allows us to demonstrate post-processing trade-offs in real time. We can adjust the cascade leakage to model the parity disclosure budget required during error correction, tweak the PA leak scale to alter how aggressively privacy amplification strips away mutual information, and set a dedicated security margin as a final safety buffer before key release. The impact of these choices is beautifully aggregated in the leakage breakdown donut. This multicolored chart explicitly details the exact bit cost of your security parameters, showing how bits are systematically sacrificed across cascade corrections, privacy amplification, and security margins to guarantee an information theoretically secure key. For deeper post-processing analysis, the workspace provides critical microscopic and macroscopic views. The bit agreement raster maps the exact index-by-index match and mismatch of the sifted keys, supported by a live cumulative agreement curve. Concurrently, the key length trend graph charts the final key yields across sequential runs, which is perfect for demonstrating parameter sweeps during lectures. The platform also enforces rigorous educational safe operation behaviors. If you push the channel disturbance too far and breach the configurable QBER safety threshold, which defaults to 50%, the platform mimics a prudent quantum network defense. The run is automatically aborted, an informative safety message is logged to the console, and the software refuses to commit these unsafe figures to your plots or trend history, reinforcing proper cryptographic intuition. Every successful run is archived in the run history table for easy cross-comparison. For seamless multitasking during live presentations, you can pop out the console or the history table into dedicated windows or toggle full-screen mode. Once your experiments are complete, exporting your findings is effortless. Using the on-screen action buttons, you can save raw console logs, export the complete run history to a CSV, and capture high-resolution PNGs of all active plots. You can even generate a comprehensive PDF summary report or output the final shared secret key in a clean hex representation for downstream hardware demonstrations. From high-level workflow visualization to rigorous post-processing analysis, Visual QKD Pro transforms complex quantum cryptography into an accessible, actionable, and deeply visual learning experience. Thank you for watching. Visual QKD Pro step-by-step software execution and safety logic flow. Step 1. Set parameters, choose qubits and noise. Step 2. Toggle threat. Include Eve, optional. Step 3. Run simulation, click the green button. Step 4. Check QBER's noise, greater than or equal to 50%. No. Step 5. Output keys, post-processing budgets. Step 6. Session archive, update history and export. Yes. Run aborted console error alert,